Very good morning to all of you. Good evening to all of you. Sorry, students. Okay, we have already started with D and F block. In first class, we have studied about the electronic configuration. Then we have studied about magnetic property. Then we have studied about oxidation state. Today, we are going to study about color. And after the color, we are going to do other properties of D and F block element. And today, I am also going to cover potassium dichromate and potassium permanganate. Okay? Chalo. So for in order to know the color again, you should know this electronic configuration. First, look beta, if it is 21, 3D1, 22, 3D2, 23, 3D3, like this way. Till 30, you should know. Now, in order to understand color in a better way, okay, so we are going to study about how many types of orbitals are there. D may there are 5 orbitals. How many orbitals are there in D? Tell me. 5, right?
Yeah.
Yeah. And in this 5 orbital, 3 are between the axis and 2 are along the axis. 3 are between the axis and 2 are along the axis. Look, beta. I'll show you here. Oh, look here. Yeah. Look, can you see this beta? These two. D may how many orbitals are there? Total 5. Okay. Wherever square word is there, it is on the axis. Can you see these are on the axis, along the axis? So how
Hmm.
many are along the axis beta? These two. Dx square minus y square and dz square. We call them as EG. And this, can you see whenever they have written x, y, y, z, square word is not there. So they are between. Whenever I'm writing x, y means it is between x and y. Wherever I'm writing x, z, also it is between x and z. Wherever I'm writing y, z, then it is between y and z. Can you see this? Right? So now,
Yeah.
what is going to happen now? Look, whenever I say, let us say copper sulfate is blue color. Copper sulfate is what, beta? Blue color. So what happens, beta? Copper is a D block element. So this is my copper. Now to this, who is approaching? Sulfate is approaching. Now sulfate can approach beta in various ways. It can approach beta between the axis or it can approach along the axis. Suppose beta if it is approaching between the axis or along the axis. Suppose we are going to take the first case. If it is approaching along the axis, how many of them are there? Tell me, 2 orbitals are there or not? Tell me. Okay, copper will also have electron. This ligand means sulfate is approaching. It will also have electron will repel. So these 5 orbitals, earlier they were having same energy. Now they will break into 3, 2. Because this energy, e.g. this 2, between the axis will repel, they will experience more repulsion. So their energy level will increase. Is this clear? Suppose I am copper and sulfate. You all are ligands. You are approaching me along the axis. So my
Ah.
energy level will get disturbed due to the
So it
repulsion.
will decrease.
Yeah. So Eg will go up, 2 orbitals will go up and 3 will remain below. Suppose beta, if it would have approached between the axis, then what would have happened? Between approach करता तो कौन ऊपर जाता था बोलो बेटा? 3 लोग ऊपर चले जाते बेटा. This
And two people will remain behind.
so here Eg will remain below and T2G will go up. Okay, this generally happens when there is a tetrahedral complex, and this generally happens when there is octahedral. Okay, अभी कलर के लिए क्या कंडीशन होता है? So that we are going to study. I want all of you to keep my notes in front of you. So look here, beta, we are starting with this. I have written from, look, last class was still here. I have done oxidizing and reducing agent. Now, how many types of orbital are there? D may beta tell me 5 types. 2 are along the axis, e.g., and these are between the axis. Now, how the color is visible? Look, a human eye can see color only in which range? Visible range. In which range? Visible range.
Visible
So
ray.
look, I have written here color is, we can see color. Look. Human eye can see color in visible light. Achha. We see which color generally beta? We see transmitted light, which is complementary to the absorbed light. Now the concept of color was given by whom beta? Munchel. What he said beta? Look here. Okay, he gave us this concept. Normal white light hota hai beta. That is what beta? Vibgyor. That is what? Vibgyor. Vibgyor.
Review.
व्हाट इज सेड कि आई को कैंसिल कर दो, आई को कैंसिल नहीं, आई होता है, बट फर्स्ट व्हाट यू हैव टू डू, यू हैव टू राइट एक्स एंड देन बाइसेक्ट दिस एक्स लाइक दिस, एंड आई विल स्टार्ट फ्रॉम हियर। विबग्योर है तो वी लिखने का, आई नहीं लिखने का, आई को कैंसिल, बी जी वाई ओ आर ऐसा लिखने का। अच्छा, नॉर्मल व्हाइट लाइट कंसिस्ट ऑफ ऑल दिस फ्रीक्वेंसीज बेटा। I is also there, here somewhere it is there, but we are not writing. Now, when suppose there is an object, beta there is an object. So ये आपको object white दिख रहा है, white क्यों दिख रहा है? इस पे बेटा all this light will come, all vibgyor will come, and all will get reflected back. So who's the complementary beta? The opposite ones. These are the complementary. Violet का complementary कौन है बोलो बेटा? Yellow.
Yellow.
Blue का orange. Red का green. So if violet and yellow will come, na beta, they will cancel and it will become white. Blue and orange will come together, then it become cancel and it will become white, colorless.
Oh, that's why the toothpaste are purple in color now.
Huh?
Nowadays, the toothpaste, the Colgate toothpaste,
Uh,
they've come up with a purple toothpaste, the color correcting theory.
yes, yes, yes. Now red and green, when they will come, they will become white. Now suppose this object is there. So what is happening? All this should be for human eye, it should be in visible range. Huh? Let me tell you. So suppose beta ये normal light आया, टकरा के all are getting reflected back. So what is happening? Violet is also getting reflected, yellow, blue, orange. So when all will come together, it will become white or not? Tell me, right? Now, suppose you can see this black object. What is happening? All light are coming and everything it is absorbing. So nothing is going back. So it appears to be what? Black. Now suppose you can see this green color, beta. So what is happening in this green color? This object is absorbing which one beta? This, it is absorbing this. ये रेड को एब्जॉर्ब कर रहा है, बाकी सबको बाहर भेज रहा है, बाकी सबको ट्रांसमिट कर रहा है। तो वॉयलेट एंड ऑरेंज क्या हो जाएगा बेटा? वॉयलेट एंड येलो कैंसिल हो जाएगा, ऑरेंज एंड ब्लू विल ऑल्सो कैंसिल इफेक्ट। अच्छा, रेड इसने एब्जॉर्ब कर लिया। सो नाउ व्हाट इज कमिंग आउट? टेल मी। रेड इट हैज एब्जॉर्ब, तो ग्रीन को कैंसिल करने वाला कौन था? रेड था, बट रेड एब्जॉर्ब कर लिया, तो बाहर क्या आ रहा है बोलो?
Green.
हाँ, तो हमको कौन सा कलर दिखाई दे रहा है? ये क्या था तुम्हारा? एब्जॉर्ब।
So
एंड दिस
even
इज
the
विच?
leaves absorb the red color and then they reflect the green color.
Yes, and this is the transmitted. Now, suppose if any object is there, suppose if it is absorbing blue color and reflecting all, transmitting all others, तो what color you will see? अगर ये blue absorb करेगा तो क्या दिखाई देगा आपको बोलो? बाकी सब वो
Orange.
रिफ्लेक्ट कर रहा है, तो आपको कौन सा कलर दिखाई
Orange.
देगा? अरे कॉम्प्लीमेंट्री,
Orange.
ऑरेंज। आर यू गेटिंग इट? नाउ suppose beta, if there is an object which is absorbing beta both this, so we'll see the mixture of these two. Are you getting it? You will say sir, we can see many color, light pink, this pink, that pink, so वो इसके suppose इसके आसपास का होगा तो इसके आसपास का रेंज दिखाई देगा. So color was explained by whom? Munchel, color wheel. Have you understood this wheel? Okay. Now कलर दिखने के लिए क्या होना चाहिए? व्हाट शुड बी देयर? देयर शुड बी जंपिंग ऑफ इलेक्ट्रॉन फ्रॉम, देयर शुड बी डी ट्रांजिशन. नाउ व्हाट इज दिस डी ट्रांजिशन? आई एम गोइंग टू एक्सप्लेन यू. Now imagine beta, this was, suppose this is my copper, this is my copper metal. Who is approaching this? Sulfate is approaching. Let us say बाहर से कौन अप्रोच कर रहा है? सल्फेट या कोई भी डी ब्लॉक एलिमेंट है. So now first condition is what beta? It should have unpaired electron. So can you say this is having unpaired electron or not? Tell me. Okay, these three orbitals were between the axis and two were along the axis. And my ligand is approaching beta. Where it is approaching? बोलो, along the axis. तो कितना अगर ऊपर जंप मार के चला जाएगा? दो ऊपर जाएगा कि नहीं? And three will. So it is
Yeah.
called as beta degenerate orbital are splitting. Crystal field splitting will take place. Now this unpaired electron is here beta. Can you see this is unpaired here or not? Tell me. Now here it will absorb light. It will what it will do beta? It will absorb. Let us say it is absorbing. What was the complementary color? देखते beta. It is absorbing. It will absorb light. If it absorb light, what will happen to this electron? Electron will absorb light. So from lower state, it will jump to which state beta?
higher state.
Higher state. Acha, once it will go, if once it goes into the higher state, once it goes into the higher state, it becomes unstable. It again wants to come back to its normal state. Okay. So suppose when once it is going at this higher state, it is absorbing, let us say, it is absorbing red color. क्या absorb कर रहा है?
Red color.
Red. It is absorbing here which color? Red color. Red color का frequency. नाउ अगेन बेटा ये इलेक्ट्रॉन ऊपर गया ना बेटा, देख ना ये नीचे से कहां पे जंप मार दिया, ऊपर गया. तो नाउ अगेन इट विल कम डाउन. It will, so in order to come down, it will emit some energy or not. So it is emitting this energy. It is transmitting light. And we are standing here. Can you see? I'm seeing from here. तो हमको कौन सा दिखाई देगा? रेड का कॉम्प्लीमेंट्री कौन था बोलो? Who was the complementary of red?
Green.
तो we will see which color? Green. Acha, now in
So,
this process, in entire process, have you noticed one thing? There should be unpaired electron, and this electron should jump. This electron should what, beta?
jump.
अच्छा बेटा, अगर यहाँ पे इलेक्ट्रॉन होता ही नहीं, देर इज नो इलेक्ट्रॉन हियर, सपोज इफ इट इज D0, नो इलेक्ट्रॉन, तो विल एब्जॉर्प्शन अकर? नो ना बेटा. विल
No.
ट्रांसमिशन अकर? नो. नाउ सपोज इफ इट इज D10, पूरा भरा हुआ होगा बेटा, ये पूरा भरा हुआ है D10, तो बेटा इलेक्ट्रॉन आर देयर, बट ऊपर जंप मारने के लिए जगह है क्या?
No.
Oh, so basically, beta, what is that? So D0 and D10 will be colorless. D0 and D10 will be what?
Colorless.
Because there is no DD transition happening. In this beta, can you see one electron is jumping and it is going up? Can you see? So this jumping of electron from lower d orbital to higher d orbital, we call it as DD transition. We call it as which
So
transition?
what
Huh?
causes it to jump?
What?
What causes it to jump?
Arey beta, first it will get split or not, tell me.
Okay, imagine first you take an example.
Okay, now
Red.
look. First of all, beta, copper is there and sulfate is approaching, let us say. So this will
Hmm.
split. Now, once it will split, then beta in environment there is light, so it will absorb light, if visible light, if it is absorbing at that particular point. So this electron will jump.
Oh,
So the visible light is causing the jump.
okay.
Okay.
Yeah.
So basically now this is an entire thing in exam point of view. What you have to remember? What is the condition for colorless? You remember? Colorless is what?
D10. D0 to D10.
And if it is D1 to D9, then it is color.
Color.
Now in exam, what
So you
question?
don't remember all of the process?
What?
Do you have to remember the whole
No,
process?
no, no. I'll tell you what type of question. First you understand. First you understand, and then I'll come to the question. I'll open the question beta. Okay? Yeah. Now, in exam, suppose if I give you this question, scandium 2 plus and scandium 3 plus. In exam, they will just ask you whether the particular compound is colored or colorless. So now normal scandium is how much beta? 21. So it will have 3D1, 4s2 or not? Tell me. Now if it is becoming scandium 2 plus, so what it will lose? How many electron it will lose? 2, na? So what I'm getting? 3D1 I'm getting here or not? Tell me.
Yes.
हाँ, तो D1 आएगा तो कलर्ड होगा या कलरलेस?
Color.
Now suppose in exam I'll give you scandium plus 3 and I'll ask you whether this is colored or colorless. So for scandium, how many electron it will lose?
3.
So 2 from here and 1 from here. So D0 आया तो colorless. Easy.
Color.
Now I'll
Yeah.
give you one more example. I'm giving you copper 1 plus and copper 2 plus. This is cuprous and this is cupric. Copper is this 3D10 4s1,
Hmm.
right? So if it is Cu1
Yeah.
plus, then what will happen? Tell me how many electron it will lose?
And lose.
अबे छिंगी 1 इलेक्ट्रॉन ना येड़ी.
Ah.
हाँ, तो क्या बचेगा बोल?
3D9.
कैसे 9? Copper and chromium and copper was anomalous or not? Tell
And
me.
so it's losing one electron now.
हाँ, तो it is losing from 4s1 ना.
So then it'll be 10.
हाँ, तो that is what I'm saying ना. So 3D10. So D10 will be what? हाँ,
Colorless.
suppose if I give you Cu2 plus, then how many electron it will lose? 2.
Then it'll
1
lose
from
one
here,
from
1 from
S and
here.
one from D.
हाँ, तो colored.
Color.
Okay, so they will just give you iron and they will ask. Now what type of question they will ask? First, suppose beta, if they say write a note on color of D block for 2 marks question or 3 mark, then you'll just write whatever I have given, like from here till here. Okay, here till here, example. And one more point you are going to write, I'll show you. First, let us discuss the question. Uh, Era, what is the question now? See, what is written here? Read this question, anyone? Ryan, beta, read what it is written.
Why
Melroy,
salts and
yeah, Ryan, read, huh? Why these salt
why
are
salt?
colorless? What is given?
Because they all are diamagnetic.
Diamagnetic नहीं लिखने का यहाँ पे ये डी. Ryan's
Because they
scandium
all
of what? 21. So 3d1, 4s2. So it loses 3 electrons. So 2 from here and 1 from here. So what I'll get? D0, colorless. Titanium normal, science teacher 22 it is. 3d2, 4s2. Now here what they are given? कितना इलेक्ट्रॉन लूज करेगा रायन? 2 from here, 2 from here. So it loses 4 electrons. So what you'll get? D0 or not? Tell me.
D0.
Yeah,
Yeah,
vanadium. Science teacher vary. The vanadium is 23. So 3d3, 4s2. How many electron it will lose? 5. 2 from here, 3 from
five.
here. So it is what beta? 3d0. D0 means
3D0.
what? Colorless. Have you
Colorless.
understood what question will come?
So they all are diamagnetic. So why can't we just say they're diamagnetic?
Shut your mouth, beta. Yeah, what you are saying is true. So that is why I was explaining this, na, beta. Whichever will be diamagnetic. So but we don't have to write diamagnetic. We have to write the exact reason. Basically, beta,
But
Zia,
we have to
what
show
I
each
told you,
electron
beta, if
losing.
D0 D, तो what, मैं तुमको अभी शॉर्टकट बता रहा हूँ, सुनो. एग्जाम में अगर डाया पैरामैग्नेटिक पूछेगा तो D0 देखो. D0 D10 is diamagnetic and it is as well as colorless. Have you understood now?
That I
Yeah.
understood.
Then
But
beta, if
then
they
do we have
say
to show?
paramagnetic beta, then what will say they are what beta? Colored. Okay. But there are few exception also. Yeah. Now tell me, what is your question?
Sir, if do we have to show the electrons losing or do we just write they're diamagnetic
But
or they
no, beta,
have
you'll have to show
zero
that.
DN?
No, you have to show that. Right? Because that
Acha.
is how they will give you marks. No? Because how they will come to know you are writing properly. That main reason why I am giving these notes and why am I highlighting this part for colored.
Okay, okay, got
And
it.
I'm trying to make things simpler for you, right? So look, this I have given a condition for color, and this is for colorless. That's it. Easy. Now here there
Yes.
is one interesting case. Melroy, can you see this? Hello, Melroy.
Yes, sir.
Potassium dichromate. Now potassium dichromate mein, what I'm going to write, potassium oxidation number is +1. So this is how much beta? +2. One oxygen is -2. So this will be how much? -14. So total should be 0. So what number I will add? +12. But beta, this +12 is for how many chromium? 2 chromium. So for 1 chromium, it will be how much? +12 divided by 2. So it is +6. Now, normal chromium atomic number was beta 24, but it was exceptional case. Remember 3d5, 4s1, 1 electron used to jump, half filled. Now here in this, my chromium is what? +6. So when chromium will become +6, so how many electron it will lose? Tell me 6 electron it will lose. 1 from here and 5 from here. So it has become D0 or not? Tell me. Yeah, Melroy, it has become D0 or not? Tell me.
Yes, sir.
So it should become colorless or not? Tell me. But
Yes, sir. Should be.
potassium dichromate in real life, it is orange colored. So abhi, now you'll say, sir, what? Just now we did. So therefore, I have written here exception. Can you see? Sometimes, beta, in spite of having D0, a compound can be colored. Now, then scientists thought, why it has become colored? So what is the main reason here? I'll explain you. Look. In potassium dichromate, beta, if you see chromate, what is the valency of chromate? 2 minus. My chromium was having how many electron? Tell me, it was having D0. So what scientists told that this one electron from this charge will get entered into this d orbital. So electron is getting transferred. This negative entire radical was having with charge negative, na? So one electron might be jumping into the d. So now electron is getting transferred. So electron is having charge or not, tell me. And it is getting transferred into 3D. So now 3D 0 will become 3D 1. So charge is getting transferred. So therefore potassium dichromate is colored due to charge transfer. Look, I have shown here. It should be colorless, but it is orange color. So why it is orange color? So one electron from here it is getting charged. So therefore it is colored due to charge transfer. Zia, have you understood this?
Yes.
Okay. Similarly, now you only tell me, Zia, this Camino 4, potassium permanganate. One potassium is how much, beta? Plus 1. One oxygen is
Yeah.
minus 2. So this is minus 8. So Mn should be how much? Plus 7 or not? Tell me.
Yes.
Manganese atomic number is 25. So 3d5, 4s2. But here it is what, beta? Plus 7. So in order to become plus 7, how many electron it will lose? 7. 2 from here and 5
7.
from here. So what it will become? D0 or not? Tell me.
Yeah.
So therefore it
Yes.
should be colorless or not? But we have studied
Yes.
potassium permanganate is in purple color. So why it will be colored? Same reason. In MnO4, permanganate,
Charge.
MnO4 1 minus. So this D0. So what will happen? One electron will jump into what? D. So electron is getting jumped. Electron is nothing but charge species. So charge is getting transferred. So therefore, potassium permanganate is colored due to what? Can you see? I have shown here also.
Charge transfer.
Colored due to charge transfer. Easy. Right. Hey,
Yes.
when you all are coming tomorrow for, are you all coming for physics? When you are coming for physics?
I'm not coming for physics.
Physics class.
Why?
No, अरे you can pick up the notes from the classes. Otherwise, you will come directly on Saturday, man.
Which notes? I already have the note.
DNF block.
Yeah, you gave it to us.
When I gave,
So when we were doing biomolecules ka last part,
so all of
you gave
you
it to
collect, all of you collected the note, but then Nerissa was
only Nelsa
asking,
doesn't have.
huh?
Only Nelsa doesn't have.
Okay,
Only Nerissa doesn't have
okay,
because
good,
she
good.
didn't come back.
Melroy, you are having the notes. Ryan, you are having the notes.
We'll have to collect it.
You have to collect.
I'm good.
Melroy, you have the
You
notes.
were there.
Where? I wasn't there for
Yes, sir.
those.
I have the note.
ओके वेरी गुड चलो जिसके पास है बहुत अच्छा है दिव्या तेरे पास है नोट्स
Biomolecule. Yeah.
Yes, sir.
ओके so these are the question they will have. Now one beta there are 3 points which I want you to write. Okay, color is also due to beta there are 4 this they ask very frequently in board. So what is the condition? This 4 I want you to write in the notes it right now. This is comes for अच्छा बेटा अभी मैं तुमको बता देता which page I have done in the textbook बेटा listen. Look, we started with page number 172. In your textbook, beta, we did this 172. Color, can you see? We see color, visible range, and all these things they've explained. This is with your Munchel color wheel. Okay, blah, 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 they have written. Look, beta, I'll tell you, beta, wherever you will see D0 and D10, it will be what, beta? Can you see here it is D0, D0,
I'll be
and
colorless.
D10. तो देखो ये D0, D10 colorless है बाकी सब
Oh,
कलर्ड है दिखाई दे रहा है कि नहीं बोलो
yeah.
Okay, now this is very important. This come for 2 marks, and I want you to write it in my notes only. Write it. The notes which I given now. So what was the color? Color होने के लिए क्या होना चाहिए था बोलो unpaired electron in D, and there should be what beta DD transition. These 2 points are total 5 points are there beta. Fifth point is charge transfer. Fifth point what will write beta?
Yeah. Charge transfer.
चार्ज ट्रांसफर चार्ज ट्रांसफर का मैंने एग्जांपल दिया था ना ये पोटेशियम परमैंगनेट एंड पोटेशियम डाइक्रोमेट बट दिस टू आई आल्सो वांट टू राइट कलर आल्सो डिपेंड्स ऑन व्हाट बेटा nature of ligand therefore beta I did coordination chemistry first because you will not understand only ligand then and color also
So
depend upon job
these are all
huh?
the points on which the color depends on.
Yeah this will come this has come in board for 3 times color of transition metal is due to what so we'll write these
Okay.
5 points I'll again take
Okay.
1 2 3 4 and 5 में खाली आप ये चार ट्रांसफर लिखो बस एंड दिस इज वेरी इंपॉर्टेंट आई वांट यू टू कॉपी प्लीज कॉपी मैंने ये जो नोट्स दिया ना वहां पे एक जगह होगा बेटा कहाँ तो ये TNF ब्लॉक है ना बेटा इधर पे। कलर में कहाँ पे तो लिख दो ना, एडजस्ट करो ना, हियर हियर यू कैन एडजस्ट, हियर इन दिस एरिया।
Yeah, you show us the points and right.
या प्लीज दिस, प्लीज प्लीज राइट दिस, वेरी इंपॉर्टेंट क्वेश्चन। Fifth point, you just write charge transfer. Don't explain entire thing. Just तो लुक, अनपेड इलेक्ट्रॉन होना चाहिए, अनपेड इलेक्ट्रॉन होगा तो ही तो डी ट्रांजिशन होगा। Then it also depend upon nature of ligand. We have studied a ligand are strong field and weak field. And then it also studied depend upon geometry, whether it is tetrahedral, octahedral, what type of structure it is. Done? Once you
So
are done with that,
how does it depend on the geometry of the complex?
okay, whether it is tetrahedral or octahedral, the color changes, beta, because
Oh,
absorption of
yeah,
light
you said
means,
correct, correct.
yeah.
Very good.
Look here, they have given here. Look here it was 6 carbon. Can you see this cobalt ka example? 6 means it is
Yeah,
what, beta? Octahedral. Now
octa.
here it has become 4.
It's not octa, na? 8 is octa.
अबे झिंगी, ऑक्टाहेड्रल बनता है 6 में।
Acha, like that. हाँ, sorry.
अबे दिस इज अ 1 2 3 4 ऐसा, 1 इज अप एंड 1 इज बिलो, तो अभी ये ज्योमेट्री
What is
बनाएगी तो
that?
ऑक्टाहेड्रल बनेगा कि नहीं ऐसा, डायमंड
Yeah,
जैसा बनेगा
sorry.
कि नहीं?
हाँ हाँ.
ओके, तो लोग ये क्या था बेटा, pink, which was octahedral. But when the solution it changes to another complex which is tetrahedral, the color changes. Have you taken this point? Now I'll go to the next part.
Yeah, done.
Now we go to the next part. Now beta there are few points which just you will remember. That's it. ज्यादा उसमें देख बेटा, यहाँ पे मैंने अभी ये तुमको चार्ज ट्रांसफर का बता दिया था, पोटेशियम डाइक्रोमेट, MnO4। वन मोर एग्जांपल यू विल रिमेंबर, DMG, बस ऐसे नाम याद रखना, डाइमिथाइल ग्लाइकोजॉइन। Okay, now very important property, beta. Most of this I have not given in the notes, huh? But I will read from the textbook. This comes in exam. We have done few example in polymer chemistry. Hey, have you studied many reaction, beta, in D block element, beta? So most of the D block element are used as a catalyst. They are used as a
That's nice.
catalyst. You might have studied many reaction, beta. You know, Hebber's process में Fe, remember beta?
Yeah,
हाइड्रोजनेशन ऑफ
yeah.
ऑयल निकल, अल्केन टू अल्किन निकल, प्लेटिनम, ये सब बहुत ही बार यूज होता है। तो व्हाई दे
Hmm.
आर यूज्ड, ओके, इन कैटलिस्ट? वेरी इंपॉर्टेंट क्वेश्चन बेटा। ओके, तो व्हाट इज द मेन रीजन व्हाई डी ब्लॉक एलिमेंट आर यूज्ड एज अ कैटलिस्ट? व्हाई दे आर यूज्ड एज अ कैटलिस्ट? तो आपको उसके लिए आंसर में आप क्या लिखोगे बेटा, ये मैं यहाँ पे साइड में लिख रहा हूं बेटा, डी ब्लॉक एज कैटलिस्ट। तो फर्स्ट पॉइंट व्हाट बेटा, vacant d orbital, then variable oxidation state, and third point what you are going to write beta, provide large surface area, provide large surface area, ये लिखना है आपको। why d block element are used as a catalyst? now beta I'll tell you the reason for this। अच्छा,
Is
catalyst
there
में
a
क्या,
page?
हाँ,
Is there a page for catalyst in the notes, or do we write it anywhere?
you write ना अलग से ऐसे नहीं, there is no page। I'll tell you beta, suppose there is a reaction happening between A and B, So what should happen, beta? This A and B should come close, na beta? So what will happen? Suppose this is my D block element. It provides large surface area. Then A and B will come and settle on this beta. A and B ऐसा loose bond बनाएगा. Why they can form bond? Because they have vacant d orbital. Now what will happen, beta? The collision will take place between A and B. And then what will happen after some time? They will leave the surface and they will form product. New product. A and B will break down and they will form new product. C and D. Okay? Like that. But you just write this 3 point. Array, what happened to this? Why they are used as a D block? So this is the point we have to write. Bus. समझा गया?
Yeah.
Now here you have to by heart the example. That's it. I hope all of you have written this.
So 1 second.
अरे many reactants are there ना बेटा तो ये suppose this is a D block, all reactant will come close, they will form bond with this D block element. Now then collision will take place between them. Why? Because they have come close, and then the bond will break and they will form a new product. Clear?
Yes.
Okay, here you will have to now by heart. With this they ask, in who act as a catalyst for KClO3. So what will you for decomposition of MnO2? Mn is a D block element or not? In Haber's process, who is the catalyst? Fe. This they ask very frequently. Fischer-Tropsch process for synthesis of gasoline. What we use? Cobalt and thorium. Cobalt is a D block element or not? Then there's alkene to alkane. Which catalyst we are using? Nickel. Hydrogenation of oil. Clear? So in this beta we convert oil into margarine. अरे बेटा घी बनाते हैं वनस्पति घी. There are 2 types of ghee. One is that cow buffalo से हम लोग निकालते हैं वो वाला घी नहीं.
A2 cow ghee.
पाम ऑयल से हम लोग घी बनाते हैं. फ्रॉम पाम ट्री से जो ऑयल निकलता है उसको कहते हैं वनस्पति घी. That is a substitute for butter, margarine. ठीक है ना? There is रोड साइड डोसा वाला दे 3-4 ऐसा अमूल बटर का रखेगा बाद में मार्जरीन होता है. Or the honest dosa wala will say you, or honest the sandwich wala, they will say which butter, Amul butter, then they use Amul butter. And then if you say normal, then normal one is cheaper. So uska price kam hota hai. Anyways, then beta in 10th standard you have studied preparation of sulfuric acid mein beta. What we are using here catalyst, platinized asbestos. You have to remember the name. And beta in remember beta we have studied there where in पॉलीमर चैप्टर में याद आ रहा है. पॉलीमर में वी हैव यूज्ड व्हाट बेटा? जिगलर नाटा कैटलिस्ट. रिमेंबर ट्राई इथाइल एल्यूमिनियम एंड टिटेनियम क्लोराइड. दिस इज नोन एज जिगलर नाटा कैटलिस्ट. Which catalyst? Ziegler Natta. So who is there beta? Can you say titanium is a D block element or not? Tell me. Right?
Yes. Yeah.
चलो. So D block element are used as a catalyst. इतना समझ में आ गया?
Yeah.
Okay. Then beta they form interstitial compound. Interstitial compound क्या होता है? Suppose this is a D block का metal. ये D block के elements है बेटा. Suppose this is Fe. चलो. अभी इसके अंदर interstitial space दिखाई दे रहा है बेटा. ये छोटा छोटा जगह है वहां पे अलग अलग एलिमेंट आ सकता है. In the interstitial space. So where these element are entering interstitial space में कौन आएगा? ये सब छोटा छोटा एलिमेंट कौन होता है बोलो बेटा? हाइड्रोजन, कार्बन, बोरॉन, ये सब छोटे छोटे एलिमेंट आएंगे. राइट? नाइट्रोजन, ऐसे small element can enter into their interstitial space. So can you see when small atoms like carbon, nitrogen are trapped into the crystal lattice of D block element, interstitial compound are formed. बस समझ में आ गया? Now what question they will ask? देखो this compound are called interstitial compound. Okay? अरे स्टील हम लोग स्टील के बर्तन यूज करते बेटा ये. राइट ना बेटा? तो इट इज एन एलॉय ऑफ दिस थिंग ना Fe. तो इसमें इंटरस्टिशियल कंपाउंड भी होता है. एनीवेज अच्छा इसका ना दे विल आस्क वन दिस प्रॉपर्टी. इंटरस्टिशियल कंपाउंड का प्रॉपर्टीज. व्हाट आर द गुड प्रॉपर्टीज? दे आर हार्ड एंड गुड कंडक्टर ऑफ हीट एंड इलेक्ट्रिसिटी. Okay, their melting point is higher than the pure metal. Why high हो गया बेटा? Because what has happened बेटा? Intermolecular space have been filled, so it won't melt easily. This is very interesting question. their density is less. Hey, what is density is here? Density is what?
Mass upon volume.
Acha, abhi beta, suppose this is an interstitial compound. Earlier there were only these atoms, right? Na? So there are
Yeah.
6 atoms. तो इसका मास कितना हो गया बेटा 6. वॉल्यूम तो सेम ही है ना बेटा. लेट अस से वॉल्यूम इज
Yeah.
10. So what should be the density? 0.6 ना बेटा, right? Now
Yeah.
I'm adding few things to it. ये देखो बेटा, इंटरस्टिशियल ऐसा डाला तो मास बढ़ा के कम हो गया, बोल बेटा.
Oh.
कार्बन हाइड्रोजन इसमें डाला तो मास बढ़ेगा कि नहीं, बोल.
Yeah, it'll increase.
हाँ, तो सपोज मास 7 हो गया तो डेंसिटी कितना होना चाहिए था तेरा, बोल बेटा. 7/10, तो 0.7 होना चाहिए था ना बेटा, तो डेंसिटी शुड हैव इंक्रीज ना बेटा.
Yeah.
बट व्हाट वी हैव रिटन हियर, डेंसिटी इज.
Decreases. And
हाँ.
it's less than the parent
हाँ,
method.
ऐसा क्यों होता है, रीजन मैं बताता हूँ. Whenever this molecule will enter into interstitial space na, so they expand. They will expand.
Expand.
So instead of when once this molecule earlier is कितना जगह ऑक्युपाई कर रहा था, ये ऐसा था नॉर्मली, ये ऐसा था बेटा. बट वंस दे इंटरस्टिशियल स्पेस में जाएगा ना बेटा, तो ये जो मॉलिक्यूल है ना बेटा, दिस एटम मतलब दिस आयन का पीस, इट विल एक्सपांड, ऐसा एक्सपांड हो जाता है. तो एक्सपांड हो गया तो देख मास बढ़ा, लेकिन वॉल्यूम ज्यादा बढ़ा के नहीं, बोल बेटा.
So the volume increases when it.
हाँ, तो वॉल्यूम लेटे से 20 हो गया. तो दिस आंसर विल नाउ कम व्हाट बेटा, लेस देन 0.6 और नॉट, टेल मी. क्लियर. ओके.
Yeah.
सो व्हाई डेंसिटी इंक्रीजेस, ये बुक में नहीं दिया
If
एक्सप्लेनेशन.
the volume
हाँ,
increases.
because once this element, small element enter into interstitial compound, their volume increases.
Okay.
Okay. Clear.
Yeah.
And they are used as a powerful reducing agent. Clear.
Yes.
And they are chemically inert also. Okay. Tungsten carbide is used in cutting tools. These are all interstitial compound. Iron carbide is used in manufacture of steel. Now we go to the next property of D block. Okay. We are going to study now initial part. आप बोलेगे सर क्या उल्टा सुल्टा, हाँ मैं जैसा बोल रहा हूँ वैसे ही पढ़ो. ओके. तो कैटलिस्ट में what type of question they will ask, in which process which catalyst is used. Then in interstitial compound में what are interstitial compound, they will ask, and what are the properties.
Proper.
Then beta we go to the next physical property में we go to the next part, and that is melting point and metallic character. They will ask, write a note on the melting point and metallic character of transition element. Clear. Okay.
Yeah.
Now, first of all, metallic character is directly proportional to number of unpaired electron. Now, you only tell me, beta, who's having maximum unpaired electron in this? अपना इलेक्ट्रॉनिक कॉन्फ़िगरेशन पे बहुत सारा आंसर है. You look at this chart. Who's having maximum unpaired electron? देखो बेटा, इसमें स्कैंडियम में there is 1, टिटेनियम में 2, वेनेडियम में 3, क्रोमियम में कितना होगा? 4 होगा, या एक इलेक्ट्रॉन यहां से जंप करेगा तो कितना हो जाएगा?
5.
हाँ, 1 electron will jump from here, so it becomes 3d5 and this become 4s1. तो ये भी अनपेयर्ड हो जाएगा कि नहीं? So chromium has the
Yeah.
highest. Then beta, can you see
But
pairing
even
is हाँ,
even manganese has now.
मैंगनीज में 5 है ना बेटा.
So even that has 5.
ये भी झिंगी है,
Chromium.
क्रोमियम में 6 हो जाएगा कि नहीं? पहले क्या था,
अच्छा.
4s2 3d4 था ना, तो 1 इलेक्ट्रॉन विल जंप फ्रॉम हियर. तो डी में कितना हो गया?
हाँ.
5. और ये भी अनपेयर्ड है कि नहीं, बोल.
अच्छा, sorry, yes.
हाँ.
And
ओके. तो बेटा भी सुनो, मेटेलिक कैरेक्टर इज डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन. तो जितना ज्यादा अनपेयर्ड इलेक्ट्रॉन होगा उतना स्ट्रॉन्ग बॉन्ड बनेगा. तो हु विल हैव द हाईएस्ट मेटेलिक कैरेक्टर?
chromium.
हाँ, तो स्कैंडियम से लेके क्रोमियम तक बढ़ेगा, फिर धीरे 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 क्या होगा, कम होगा, बिकॉज पेयरिंग हैज स्टार्टेड और नॉट, टेल मी.
Yeah.
ओके, सो नाउ लुक एट दिस ग्राफ. ओके, दिस इज अवर 3D सीरीज. यहाँ पे स्कैंडियम भी है, मैं बता दें, स्कैंडियम, दिस इज 3D सीरीज. 3D के नीचे पीरियोडिक टेबल में कौन होगा? 4D. देन क्या होगा? 5D. अच्छा, मेटेलिक कैरेक्टर बढ़ेगा तो बॉन्ड स्ट्रांग हो जाएगा, तो उसको मेल्ट करने के लिए मुझे ज्यादा एनर्जी देना पड़ेगा कि नहीं? आई हैव टू गिव मोर एनर्जी, राइट? तो इन 3D सीरीज हु शुड हैव द हाईएस्ट मेल्टिंग पॉइंट, कैन यू सी? अरे बेटा, it has maximum unpaired electron or not? Tell me, Zia.
Yeah, I understood, Probin.
So similarly, 3D के नीचे कौन होता है? 4D. 4D के नीचे क्या होता है? 5D. अच्छा, as you go down,
Hmm.
beta, what happens? Their mass also increases, not? Atomic number increases, so mass will
Yeah,
mass.
mass also.
So then in 4D series, who has the highest boiling point? And in 5D series, who has the highest? Wolfram. Wolfram को हम लोग क्या कहते हैं? टंगस्टन.
Oh, अच्छा, okay.
हाँ बेटा, इलेक्ट्रिक बल्ब आपने देखा? इलेक्ट्रिक बल्ब, वो येलो बल्ब आता था पहले, अभी तो बहुत रेयरली.
It has high
तो हाँ, उसमें
resistance.
बेटा क्या होता था बेटा? टंगस्टन फिलामेंट यूज करते थे.
Thanks.
वाई?
Yeah,
वाई इट वाज यूज?
because
फिजिक्स में
it
पढ़ा है कि नहीं?
very high boiling point.
बॉइलिंग नहीं, मेल्टिंग. सॉलिड फॉर्म
Sorry,
में.
melting point.
हाँ,
Yeah,
अब नाउ हैव यू अंडरस्टूड व्हाई इट हैज हाईएस्ट मेल्टिंग पॉइंट बेटा? मैक्सिमम नंबर ऑफ
because it
अनपैड.
has a lot of resistance.
And secondly beta, it also depend upon the crystal lattice. Look, there is one. Look, मुझे melt करना है. When I can melt a thing beta, first of all, the bonding in my atom should be what? Strong.
Very strong.
And my packing should be also strong. Now suppose there is
Very
this and
tight.
this is this. But here beta, can you see packing is weak, na beta? So it can break easily. But here many atoms are there. So breaking is also difficult or not? Tell me. So look,
Yes.
melting point and metallic character depends upon what beta? Number of unpaired electron and packing efficiency. What type of it? BCC, FCC. Remember we have done in solid state. Clear है?
Yeah.
ओके, तो एग्जाम में बेटा मेल्टिंग पॉइंट बॉइलिंग पॉइंट अगर आएगा तो व्हाट विल से बेटा? मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट इज डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन. सो मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट इंक्रीजेस अप टू क्रोमियम एंड देन इट गोज ऑन डिक्रीजिंग. बट आपको ये दिमाग में ये भी आएगा, सर ये एमएन का क्यों इतना ड्रॉप हो गया? वाई? टेक्नीशियम का क्यों ड्रॉप हो गया इतना सडनली? Because manganese was having 5 and Fe was having only 4. But why manganese and technetium dropped? So beta, I told
Because
you 2 points. It depends upon what beta? Number of unpaired electron and packing. So in magnesium
yeah.
and technetium, the packing is what? Beta, weak. So packing efficiency. Clear? Okay. Right? Hello.
Yes, sir.
Okay. So this is all about your this thing. Which property we did beta? Melting point and boiling point and metallic character. Clear?
Yeah.
Melting point and metallic character. Okay, so look, metallic character is also written here. Can you see? Okay, so here what you have to remember beta, melting and this vacant d orbital, this melting point, a metallic character depends upon number of unpaired electron. Look beta, number of unpaired electron. Clear? And it also depend upon the packing. What is the packing? Whether it is SCP, HCP or BCC. Right beta? Clear. So I have done melting this thing. And why we have done that manganese and technetium, why it was exception beta? Look, this they will ask. Mn and technetium का क्या था? बोलो anomalous था कि नहीं? बोलो बेटा. अरे Zia beta, Mn and technetium was an exceptional case or not? Tell me.
Yeah.
So that was due to their packing efficiency, weak efficiency.
Hmm.
So here everything is jumbled up in textbook. But I am giving you nice way how to remember. Clear?
Yes. So
Then
NCRT, is it given the way you are
NCRT
teaching
is
us,
still
or is
horrible.
it textbook?
Still horrible. Okay.
Oh,
NCRT is still horrible. So metallic character, everything we have done. Okay. Now we have to do size. Acha, now tell me, beta, you have studied in your lower standard across the period. What happens to atomic size? Across the period, atomic size decreases or not? Tell me. Down the group, atomic size increases. So now in D
increases.
block, suppose if I'm going from scandium to zinc, so what should happen to the atomic size? अरे बोलो ना, it should decrease ना बेटा. Why atomic size decreases across the period? In across the period,
Because
number of shells
the
remains
charge
same.
increases.
Nuclear charge increases. So outer electron is pulled more closer, right?
Yeah.
But beta, here
Yes.
we have to we are going to study few things. Now we have studied there is S block, then there is P block, and then we have what beta? D block. राइट?
Yes.
अच्छा, इन एस ब्लॉक बेटा डिक्रीज इन एटॉमिक साइज इज वेरी शार्प, ऐसा जुप करके डिक्रीज हो रहा है, दिखाई दे रहा है? इन पी ब्लॉक
हाँ.
ऑल्सो डिक्रीज इज शार्प, जुप करके डिक्रीज हो रहा है। बट डी ब्लॉक में हम लोग करेगा ना बेटा, तो देर इज अ डिक्रीज, बट दिस डिक्रीज इज नॉट दैट शार्प। आर यू गेटिंग इट बेटा? ये जुप करके डिक्रीज
Yes.
हो रहा है क्या? नहीं ना बेटा, डिक्रीज हो रहा है, बट
No.
very less decrease is there. Why? Can anyone tell me? We have studied earlier in 11th standard.
What?
Why the decrease in S block is sharp across the period and P block is sharp, but here a decrease is less. Here the decrease is
Because
more.
give a hint now.
Huh?
Can you please give a hint?
Okay. In S block and P block, electron enters directly into the last shell, and in D block is enter into penultimate shell.
Ah, because of the position of S and
अच्छा, तो
P
मैं आपको
and
बता
D.
देता, नहीं एकदम सिंपल है बेटा, सुनो। इन एस ब्लॉक बेटा, लास्ट इलेक्ट्रॉन एंटर्स इनटू द आउटर मोस्ट शेल, तो इनर इलेक्ट्रॉन रिमेन कांस्टेंट, सो स्क्रीनिंग इफेक्ट रिमेन सेम। What is screening effect? Suppose beta I am in the center. There are three circles around me. In first circle there are two-person running. In second circle there are eight-person running. And in last circle there is one-person running. Now what is my job? I have to keep my eye on the person who is in the last circle. But beta, what will happen? There are two-person running in the first circle. So sometimes at a given point they may come in front of my eye or not, tell me. Similarly, there
Yeah.
were in second circle, how many person were running? Eight people. So at a particular point, they will come in front of my eye. So will I be able to see the person who was running in the last ring? No, na?
No.
अरे
No.
अंदर वाले लोग जब मेरी आंखों के सामने आएगा तो मैं लास्ट वाले को देख पाऊंगा क्या?
No. No.
तो दे फॉर्म व्हाट? स्क्रीन इन फ्रंट ऑफ मी, इसको कहते हैं स्क्रीनिंग इफेक्ट। सो नाउ इमेजिन आई एम द न्यूक्लियस and these people who are running in the different ring, they are electron. So if inner electron will come in front of my eyes, okay, in front of nucleus, so will nucleus be able to see the outer person? No, na? So what is screening effect? The shielding of outer electron from
From the
nucleus.
inner.
By whom? By the inner electrons. ठीक है,
अच्छा.
बाहर
अच्छा.
वाले को न्यूक्लियस से छुपाया किसने? अंदर वाले इलेक्ट्रॉन ने। और वो अंदर वाले इलेक्ट्रॉन ने न्यूक्लियस और बाहर वाले इलेक्ट्रॉन के बीच में क्या बना दिया? स्क्रीन बना दिया। तो
Sheet.
बाहर वाला अंदर न्यूक्लियस बाहर वाले इलेक्ट्रॉन का पे फोर्स ऑफ अट्रैक्शन क्या हो जाएगा? कम हो जाएगा।
Sheet.
तो विल दैट इलेक्ट्रॉन विल कम क्लोजर और इट विल मूव लिटिल अवे फ्रॉम द न्यूक्लियस, इट विल मूव लिटिल अवे फ्रॉम द न्यूक्लियस। तो स्क्रीनिंग इफेक्ट बढ़ता है तो एटॉमिक साइज बढ़ता है। क्लियर है?
Yeah.
तो बट इन एस एन ब्लॉक बेटा, सोडियम एंड एस ब्लॉक में सोडियम में कैसे इलेक्ट्रॉन करता था? सोडियम और पोटेशियम, मैग्नीशियम में सोडियम इज 281, मैग्नीशियम इज 282। तो इनर इलेक्ट्रॉन आर सेम और नॉट? टेल मी, ओनली आउटर इलेक्ट्रॉन इज चेंजिंग। बट डी ब्लॉक में अगर मैं इस इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखता हूं ना, तो ऐसे लिखता हूं 2891, फिर यहां पे क्या आता है? 28, आर यू गेटिंग इट बेटा? 28, सॉरी, 2810 2। पता है ना, डी में जाएगा ना, 3D1 3D2, वी हैव डन ना बेटा। 4s2 में कांस्टेंट होता था कि नहीं? फिर एक एक डी में अंदर जा रहा था कि नहीं इलेक्ट्रॉन?
हाँ.
तो यहाँ पे क्या हो रहा है? बिकॉज द इलेक्ट्रॉन, तो तेरे को एकदम इन शॉर्ट में बता दो कैसे आंसर लिखेगी। इन एस ब्लॉक द डिक्रीज इज वेरी शार्प because the outer and S and P block, the electron enters directly into the last shell. So screening effect screening effect remains constant. So overall decrease is very high. Clear? But in D block, last electron enters into penultimate shell. Therefore, screening increases. And as screening increases, therefore, what will happen? Overall decrease in size is less. Overall decrease in size is what beta? Less. Okay. फिर बेटा साइज ऐसा तेरा डिक्रीज होगा, बीच में ना ऐसे दो तीन एलिमेंट हो गए कि ना उनका साइज ऑलमोस्ट सिमिलर भी हो जाएगा। वाई? अच्छा, इफ आई गो फ्रॉम स्कैंडियम टू टिटेनियम, तो देख क्या होता है? एटॉमिक नंबर इंक्रीजेस। एटॉमिक नंबर इंक्रीजेस मींस व्हाट बेटा? न्यूक्लियर चार्ज इंक्रीज होगा, बिकॉज एटॉमिक नंबर इंक्रीजेस मींस प्रोटॉन इंक्रीजेस, 21 प्रोटॉन, देन 22 प्रोटॉन। सो न्यूक्लियर चार्ज बढ़ेगा तो बाहर वाले इलेक्ट्रॉन को अंदर बुलाएगा, लेकिन स्क्रीनिंग क्या कर रहा है? स्क्रीनिंग उसको थोड़ा दूर कर रहा है।
Oxygen.
So as we go
हाँ.
across the period at फॉर फ्यू एलिमेंट जितना मेरा न्यूक्लियर चार्ज बढ़ रहा है उतना स्क्रीनिंग इफेक्ट भी बढ़ रहा है, तो दे आर कंपनसेटिंग दैट. So what will happen? Their size will become exactly similar. Same नहीं, वर्ड क्या यूज किया मैंने? Similar. अच्छा बेटा,
Yeah.
कॉपर और जिंक में थोड़ा साइज बढ़ जाता है. Why it increases in copper and zinc? Because copper and zinc में D10 हो जाता है. तो मोर इलेक्ट्रॉन, तो इलेक्ट्रॉन इलेक्ट्रॉन रिपल भी करेगा, इलेक्ट्रॉन इलेक्ट्रॉन रिपल भी करेगा. तो व्हाट वी कंक्लूडेड, साइज विल इनिशियली डिक्रीज, देन इन बिटवीन इट विल रिमेन कांस्टेंट, and for last 2 3 element it will increase. So this is the graph you see here now for size. Look here, what is happening to the size? Can you see? Suppose ये मेरा scandium है and this is my zinc. Can you see this? I have written also here. So initially size is what beta, decreasing or not? Tell me. फिर ये सबका ऑलमोस्ट साइज सिमिलर है कि नहीं, बोल बेटा. एंड फॉर कॉपर
Yes.
एंड जिंक इट हैज इंक्रीज्ड और नॉट? टेल मी. कॉपर एंड
Yes.
जिंक में क्यों बढ़ा? बिकॉज ऑल इलेक्ट्रॉन्स आर पेड. 3d10 3d10 हो जाता है. बीच वालों के लिए साइज ऑलमोस्ट सिमिलर क्यों हुआ? बिकॉज न्यूक्लियर चार्ज एंड स्क्रीनिंग इफेक्ट विल कंपनसेट ईच अदर. नाउ हाउ टू राइट आंसर? राइट अ नोट ऑन एटॉमिक साइज. सो व्हाट विल राइट? Okay, atomic radii in transition element decrease from left to right. Okay, nuclear charge also increases, but the last electron enters into which shell? Penultimate. Okay, and therefore what happens? D electron offer what? Screening effect. Therefore, because of that, overall effective nuclear charge increases. Hence, the atomic radii decreases gradually. Clear? Okay, right? अच्छा, अभी आपको क्या पूछेंगे नेक्स्ट? आयनाइजेशन पोटेंशियल. व्हाट इज आयनाइजेशन पोटेंशियल बेटा? आयनाइजेशन पोटेंशियल इज द एनर्जी रिक्वायर्ड टू रिमूव द आउटर इलेक्ट्रॉन. अभी तू मेरे को बता, किसमें से इलेक्ट्रॉन यू कैन रिमूव इजिली? जिसका साइज बड़ा है उसमें से, या जिसका साइज छोटा है?
इसका साइज बड़ा है.
हाँ, तो अक्रॉस द पीरियड इन डी ब्लॉक आयनाइजेशन पोटेंशियल decreases. Why? Because atomic size decrease. Sorry, ionization potential increases because atomic size decreases.
Reasons.
Clear?
Yes.
So this is what they have written here, beta. Can you see? This is our scandium to zinc, and this is their atomic size. Can you see? It is decreasing or not? Tell me, beta. देख, decrease, 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 decrease. और इन दोनों का देख बढ़ गया. देख, कॉपर और जिंक का बढ़ा के नहीं, बोल बेटा.
हाँ, बड़ा.
अच्छा, और ये वाले लोग का वैल्यूज देख ना, ये चार बीच बीच वाले, इनका साइज ऑलमोस्ट क्या है? सिमिलर. सेम नहीं बोला मैंने, वर्ड क्या यूज किया? सिमिलर. क्लियर? अच्छा,
Yes.
अक्रॉस द पीरियड आयनाइजेशन पोटेंशियल बढ़ रहा है कि नहीं? देख बेटा, तो आप बोलेगे सर इन दोनों का तो बेटा साइज बड़ा हो रहा है तो आयनाइजेशन पोटेंशियल कम होना चाहिए था. अरे बेटा, बट दीज आर कंप्लीटली फिल्ड. कंप्लीटली फिल्ड में से इलेक्ट्रॉन निकालना टफ होता है कि नहीं, बोलो?
Yeah.
या. अच्छा, अभी ऑन द बेसिस ऑफ दिस बेटा दे विल आस्क वन मोर क्वेश्चन, दैट इज एलॉय. एलॉय क्या होता है बताओ मुझे, व्हाट इज एलॉय?
It's a mixture of two
हाँ,
metals.
तो व्हाट इज द बेस्ट कंडीशन फॉर एलॉय फॉर्मेशन?
Uh,
हाँ,
when they have unpaired electrons.
no, best condition for alloy formation is similar atomic size. What is the best condition for alloy formation? Two things are there. Similar atomic size, similar word use किया. And secondly, the crystal lattice of one atom. Suppose मैं Fe मेरे अंदर कॉपर डाला, तो कॉपर का और Fe का लैटिस दे शुड रिप्लेस ईच अदर. क्लियर है? एंड सिमिलर
Yeah.
एटॉमिक साइज. अच्छा, आप लोग ने बेटा बहुत पढ़ा रहेगा ब्रॉन्ज मेडल. ब्रॉन्ज मेडल हम लोग देते ना, तो ब्रॉन्ज इज एन एलॉय ऑफ
हाँ.
व्हाट? कॉपर एंड, अरे यार, कॉपर एंड टिन. दिखाई दे रहा है कि
Yeah.
नहीं? स्टील,
हाँ.
Fe और ये सब रहता है कि नहीं? फिर ब्रास. ब्रास इज एन एलॉय ऑफ कॉपर एंड जिंक.
Copper and zinc. Yeah.
तो तेरे को, तू मेरे को अभी बता, ये जो कॉपर और जिंक दोनों डी ब्लॉक एलिमेंट है कि नहीं?
हाँ.
अच्छा, तो डी ब्लॉक एलिमेंट फॉर्म बेस्ट. सब में बेटा डी ब्लॉक था Fe. क्यों? Why they form the best? These are the element, transition element form alloy. Why? पहला
They
रीजन
have
क्या है
similar
बेटा?
atomic structure.
सिमिलर atomic size, similar, same नहीं है. And secondly, what बेटा? Their lattice
And
will displace each other. Crystal lattice can displace each other. Clear?
replace it.
आपको
Yes.
यहाँ पे क्या पूछेगा एग्जाम में, वाई डी ब्लॉक एलिमेंट फॉर्म, तो व्हाट विल से सिमिलर एटॉमिक साइज एंड their crystal lattice displays
And
each other,
displace
and
each
then
other.
they will ask you which are ferrous alloy and non ferrous. तो ferrous alloy में क्या होगा बेटा, परसेंटेज ऑफ आयन इज मोर, निकल
Hmm.
स्टील, क्रोमियम स्टील, स्टेनलेस स्टील। नॉन फेरस में क्या होगा बोलो बेटा, एलॉयज आर फॉर्म बाय मिक्सिंग एटम अदर देन आयरन, आयरन नहीं होगा, जैसे ब्रास, ऐसे एग्जाम में पूछेंगे ब्रास इज एन एलॉय ऑफ व्हाट, कॉपर एंड जिंक। ठीक है ना, एमसीक्यू में आता है, ब्रास इज एन एलॉय ऑफ कॉपर एंड जिंक। एंड दे विल आस्क दिस यूजेस फॉर सीईटी बेटा, दिस यूजेस ये वेरी इंपॉर्टेंट। अच्छा, ब्रॉन्ज इज एन, ये भी पूछेंगे, ब्रॉन्ज इज एन एलॉय ऑफ व्हाट, कॉपर एंड टिन। मेडल बनाने में काम में आता है ना, ओलंपिक में मेडल, स्टेच्यूज, ट्रॉफीज। देन बेटा दे विल से कुप्रा निकल इज एन एलॉय ऑफ कॉपर एंड निकल, मरीन शिप्स एंड बोट के लिए। स्टेनलेस स्टील हम लोग घर पे भी यूज करते हैं कि नहीं बोलो बेटा, बर्तन, यूटेंसिल्स। देन दे विल आस्क यू निक्रोम, निक्रोम इज व्हाट, निकल एंड क्रोमियम।
Chromium.
या 80:20 गैस टर्बाइन इंजिन्स के लिए। टिटेनियम
Yeah.
एलॉयज आर यूज्ड फॉर व्हाट बेटा, फायर प्रूफ बल्क हेड्स, हाई स्पीड फ्लाइट।
Yeah.
क्लियर, एनी डिफिकल्टी टिल हियर, टेल मी, बोलो।
No.
तो अभी आप बोलोगे सर इससे रिलेटेड क्वेश्चन कैसे आएंगे, तो वी हैव डन बेटा डी ब्लॉक, हाँ पूरा डी ब्लॉक अपना हो गया बेटा।
Our
एफ
D block is done.
नो नो, ओनली डी ब्लॉक इज डन बेटा।
No, so our D block, the whole thing is done.
हाँ, डी ब्लॉक में होल थिंग इज डन, वी हैव टू स्टडी नाउ metallurgy part they have introduced into this, and F block we have to study, and two compounds we have to study, KMnO4 and that. But anyways, whatever I have done beta, I am going to do the question related to it. Okay, component of nichrome, tell me beta, nichrome में कौन कौन था बोलो।
Nichrome has nickel, chromium, and
निकल एंड
nickel
क्रोमियम,
and chromium.
निकल एंड क्रोमियम ही था।
Okay.
Then yeah, explain the trends in atomic radii of D block. So what you'll say, overall decrease in size in D block is comparatively less as compared to S and P block. Then what you'll say, in D block, as you go from left to right, nuclear charge increases, but electron outermost electron gets added into what beta, n minus 1 d orbital. So screening effect increases. So effective nuclear charge will increase, but little less as compared to S and P. Therefore, overall decrease is what, less. Then you will write, initially the increase is sharp. Then for elements which are in between, their size is similar. And for copper and zinc, it increases. Why? Because number of electron increase, all electrons are completely paired due to interelectronic repulsion.
Hmm.
Okay.
Yeah.
Then explain the trend in ionization enthalpy. So what you will say, in D block across the period, atomic size decreases. Therefore, ionization enthalpy increases.
Oops.
Okay, so this we have done. Now we have to go to what, compounds. So you want me to do the compounds right now, or we have to
Not,
do it next class?
not now.
Huh?
Next class.
Next
Next
class?
class. Next.
Next class, all of you. Hello.
Yeah.
Tell me, Ryan. Okay, no problem. We'll do it next class. ठीक है? चलो then.
Yes.
Bye bye everybody.
So you'll post the schedule today, the
Yeah, I'm
timetable.
posting. Just give me 1 hour. Within 1 hour, I'm posting. Okay?
And does it have CET test also or only
CT test,
board?
I'll keep for the. I'm keeping every Sunday. There will be CT test. Okay?
So this Sunday, which test?
I'm posting in the group everything. ठीक है? चलो.
Okay. Good night.
Bye.
Bye, sir.
Bye bye.